All right, getting ready for the STAAR. We're going to work on TEK A-3B. It's talking about rate of change. Hopefully your brain immediately thought of the word slope when you just heard that phrase, which is rise over run. As you can tell by this question below, one of the ways the STAAR can ask it is from graphs. It can also ask it from tables or algebraic expressions. We'll cover all three of those in this lesson. In question 1, it's asking us what the rate of change is, that's slope, so we have to figure out what it's rising over run. We take a look and see where it crosses nicely, and it does at every single point. The second thing we have to pay attention to is the label of the axes and what it's going by. On our x-axis, it goes by 0.5. Halfway between 0 and 1 would be 0.5. So in order for us to see how much it's going over by, we're going all the way over to 1. So how far, in order to go all the way over to 1, how far up did it have to go? It had to go up to 400. So the slope is up 400 over 1. That's change in y over change in x. 400 over 1. The answer is C. Now, one of the answers that students typically give is the answer A, because they're looking at the squares and they think, oh, it went up 1 over 1, and this one was up 200 over 1, but we didn't make it all the way over to 1. Here's 1. So that's why the answer choice A is a distractor answer. All right, let's cover another graph problem. Here, when we try and look and see where the points cross nicely, because we know we have to, it's asking for rate of change, we don't see anywhere they're perfectly crossing. So we pick the points where we think it's closest to crossing. Not really there, not really there. Also looks pretty good there. So we see what it's trying to go down by. It went from positive 10 to negative 30. So it had to go down 40, minus 40, and then over from positive 1 to positive 7, so that's plus 6. So down 40 over 6. Change in y over change in x. Negative 40 over negative 6. Positive 6, rather. And if you're good at fractions and number sense, you already know which one of the answer choices it's going to be. But if you're not, you use your calculator. Negative 40 divided by 6, and you know in your TI Inspire, if you just hit enter, it gives you back a fraction. But if you're wanting a decimal, you have to hit control enter, and it gives you the decimal, negative 6.67. Negative 6.67. And we look at our answer choices, and we see F is the closest. We know it's not exact because the graph wasn't exactly crossing at those points. All right, another graph question. Here they've given us dots, so it's convenient. It asks for rate of change, which is slope, rise over run. It went up 100. That was from 50 to 150 is up 100. And it went over 1. From 0 to 1 is over 1. So that's change in y over change in x, up 100 over 1, which is equal to just 100A. All right, we'll take a look at one more graph. We see this is another one where they're not going to be crossing at perfect places. So we find the ones where we think it's close. Could be kind of close there. Maybe it's kind of close there. Maybe here. As you can tell, it's not exact, and it's kind of a hard process. But we're going to be estimating the rate of change, so let's try it. This one went up. Well, we got to see what this is changing by. From 1, 2, 3, 4, 5. So these are each 1. So this would be from 22 up to 23. So that's rising 1 over. If this is 0 to 20, this has to be 10 in the middle, and then 5, and then 15. So it's going by 5. So that's 1 over 15. If we look at our answer choices, that's not even close to 12. It's not even close to 22. Maybe 7/10, but it's looking kind of like G would be our best answer. But let's try another one of these. Went up 1 over 10. That'll be 1 over 10. We know it's not an exact slope, and that's why they're not the exact same, because we're estimating and it's not perfect. This one's another one, up 1 over 10. This one's another up 1 over 15. So sometimes it's looking like it's up 1 over 10. Sometimes it's looking like it's up 1 over 15. Well, what's somewhat in the middle of 1 over 10 and 1 over 15? That would be G, 1 over 12. The other way you could have done this is by turning this into a decimal and turning this into a decimal and turning your slopes into a decimal and comparing it if you're not good at number sense with fractions. All right, that's it for the graphs that the STAAR has asked. Let's take a look now at tables, the way the STAAR will ask table questions. Well, how do we find slope from a table? Hopefully you remember you have to try and find out what it's changing by. From 0 to 1, it went up 1. From 32 to 39, it went up 7. Now, we have to put the y over the x. So in order to do that, we have to know which side of this table, top or bottom, is y. Well, anytime you have time, that's always your independent. That's always x. So the other thing has to be your y. So the 7 is what goes on top. So it's 7 over 1, or just 7, and that's the answer. Now, you could do it on any of these, and it doesn't have to match. 1 to 3 is plus 2, but from 39 to 53 is also a different number, and when you divide it, it will divide out to give us 7. The second way you could answer these type of questions is using your formula chart and doing y2 minus y1, x2 minus x1, and picking your y, any of these points, y2 minus y1, x2 minus x1, and you'll get the same answer. That's the same process we're doing when we just see what it's changing by. All right, so there's one table question down, and there's one more. The table below represents what is the rate of change. So we're figuring out what it's changing by. So from 12 to 3, it went down 9. From -2 to 0, it went up 2. We put the y on top, so it's change in y over change in x. That's -9 over 2. B is the answer. All right, we've done tables, we've done graphs. We're on to our last question, which is algebraic. We look here and see that it's asking us to find the rate of change, slope, of this formula. Well, y equals mx plus b. Which one of these letters represents rate of change? Hopefully you thought the m, the coefficient of the x, is your slope. That's correct. And we see this equation is not quite in y equals mx plus b form, so we can get it there. Y is equal to 3.75 plus 1.5 parentheses x minus 1 close parentheses. So we need to move this around to get it into y equals mx plus b form. We have parentheses, so we have to distribute. Y is equal to 3.75 plus 1.5 times x is 1.5x. 1.5 times -1 is -1.5. That's because a positive times a negative is negative. We have two regular numbers, so we're going to combine like terms. Y is equal to the 1.5x. Normally it always is y equals mx plus b, so we'll put that first, 1.5x. And then when we combine positive 3.75 minus 1.5, we get positive, because the positive is larger than this one, 2.25. And we know, because we're looking for rate of change, the part we care about is the coefficient to x. The slope is 1.5f. Now, if you had been a sharp student and were looking here, you could have seen that when we distribute in the original, that would be the coefficient of the x. This other stuff isn't going to change your slope. So you could have seen it by looking, if you're an expert at your point y equals mx plus b slope-intercept form. That's one of the reasons why knowing those equations is helpful. All right, that's A.3b, rate of change.